Alright, so this will be one of the first parts of our lecture for today. We are looking at a quick review so that we're all on the same page. One of the things that I want to make sure of is that the little things are being taken care of. And so this sheet is a simple voltage divider. It's not the same values as the ones that we used to test your CMOS tester, but it's the same idea. There's a power supply, there's two resistors, and there's some things going on in the circuit. I want to make sure that we're all doing this the same way. So I've got my calculator with me. I'm going to use that. I have a Texas Instruments TI-30X2S. It's got engineering features on it. So if I take and I enter something in 0.056, let's say, it will tell me that it's 56 milli something. Likewise, if I type in more than 1,000, if I type in 1,500 something, it tells me 1.5 to the third. It's always telling me things in the threes or the sixes or the nines, because in engineering we use that engineering notation rather than the scientific notation. So I like this one. It's got some other things that it does too, but for now we're just going to not worry about that. Alright, so if ever I give you any of these things, look first at your notes. We want to sketch the path of the electrons to show the current flow. I want you to label polarities on every component, show all calculated numbers to 4 digits, round correctly, use engineering notation, and use the correct metric prefixes. Let's just go through this one together so that you get an idea. I'm going to want to see these things on the papers that you hand in. So first of all, we've got a little bit of a puzzle. What do we know? We have 10 volts on a battery in our circuit. We have our wires connecting two resistors, R1 and R2. R1 is 200 ohms. R1 is 200 ohms. R2 is 100 ohms. Alright, so what do we have? Well, let's just start with our givens, and you'll see me, I like to number things so that if I screw something up I can go backwards. Number 1, I'm going to take and I'm going to write in 200 ohms. Notice I use 4 digits. I'm going to go down here, I'm going to write in 100 ohms. That's step 2. If I go over here, I know my voltage. Step 3 is 10 volts DC. Alright. So that is what we know so far. But I already didn't follow my directions. I want to sketch my current path. So I'm going to get in here and I'm just going to go like this to indicate my current path, because electrons flow from the negative side of anything all the way up. Okay, the next thing it wants me to do is label polarities. So now I'm going to label my polarities. Here's the positive and negative sides of my resistors. Alright, so I took care of that one, I took care of that one. Show all calculated numbers to 4 digits. So far so good. So it looks like the rest of my notes have to do with calculating things out. So I'm going to pull this calculator closer. Now I know that in a series circuit, my resistances are additive to get me my total resistance. So in this case, I have 300 ohms. Alright, and I know that if I take my volts via Ohm's law, look at this here. My volts are 10 divided by 300, and that's going to give me 33.33 milliamps. Really trying to do this around this camera here. I'm going to have to come up with a better method. So 33.33 milliamps, and we know that Watt's law tells us that my energy times my intensity, my volts times my amps equals my watts, my power. So if I take 10 times 0.033, that gives me 330. Am I doing that right? Oh, I'm not doing that right because I have, let's do this. Let's do it this way, 0.03333. I have 33.33 milliamps times 10 volts DC. That gives me 333.3 milliwatts. There we are. Okay, so now we know our totals. And the order that I did that is 1, 2, 3, 4, 5, 6. You don't have to label the orders, but I found when I was doing tons of these things when I was in school that it helped me work backwards if I had a mistake. Okay, so now I know the current, and we know that in a series circuit, current stays the same everywhere. So I'm going to carry my current of 33.33 milliamps through everywhere. And if I know my current and my resistance, I can calculate my voltage. And here we're just multiplying by 100, so 0.03333. Could probably go like this here. Times 100. That's 3.333. Whoops. Volts DC. Up above, if I do the same thing, 0.03333, hit the equal sign on my calculator, that gives me 33.33 milliamps times 200 ohms, gives me 6.666 volts. and that was step 9 and 10. And I know again, because of Watt's law, my intensity times my energy, my amps times my volts, it's going to give me my power. So I'm just going to leave 6.666 right on the calculator. I'm going to multiply that times 0.03333, and that gives me 222.2 milliwatts. And that's step 11. Step 12, I'm going to do the same thing. I'm going to do 3.333 volts times 0.03333. That should be 111.1 milliwatts. And that's my 12th step. Okay. Now, did I do everything that was asked of me? I calculated all numbers to 4 digits. I've got 4 digits, 4 digits, 4444, 4444. Did I round correctly? I think so. I used engineering notation. And everybody's got metric prefixes. I don't need them here because these are in, they're correct. But here I've got millis, 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 millis. So I think I'm good. So that's kind of how we're going to do this exercise. But I want you to get in the habit of using the polarities so that we understand where that's at in the circuit. It's going to come in very handy during diodes. We're going to sketch that electron path because I need to know which way the path is working for our current, because our diodes only work in one direction, unless we're dealing with Zehners, but we'll get to that. And then these other items are just good practice. Calculated digits to 4, correct rounding, engineering notation, and our prefixes. If you have any questions, then we'll take that up during our question and answer session.